So we're going to average the quiz grades. This is, again, problem 6 on the section 6, part 2. Average the quiz grades, so I added them up and divided and came out with 73.6. Anyone else also get that as the average for the quiz grades?
I got 202.
Did you divide? Well, I don't know how. I don't even know where 202.
You said divide, add them together and divide?
Yes.
Or do you got to change it to decimals?
I just added them together. I did not change it to decimals, no.
Okay.
And then quiz grades are 15%. So then we would multiply that. That part we are going to change to a decimal. And that gives me 11.04. Now, some of this stuff you could do lots of steps in your calculator. What?
Sorry, Carolyn. You came up to 73.6 by adding 100%, 90%, 95, 0, 83, and you divided it by 5.
Yes. Did you come up with something different?
No,
Or?
no. I just, yeah, no.
Okay.
I didn't try it.
Okay, try it real fast for me,
What is 11?
just in case.
Can you tell me what you just did? That on the side.
Okay, so to find the quiz grade, add the 100, 90, 95, 0, and 83. It obviously doesn't matter if you add the 0 or not, because it doesn't add to it. But you do need to divide by 5 scores.
73.6.
Okay, so good. I still got it. So then our quiz average is 73.6. So anything that has more than one score, we need to get an average before we use the percentages up at the top for the weighting. So you could go ahead and figure that weighting, or you could go down and do your other averages first. For projects, we have 2 projects. So if we add those 2 together and divide by 2, so I'd be adding these 2 together, divide by 2, because there's only 2 of them, then my average for that would be,
104.
okay, when you add it together and divide by 2, you have to hit equal before you divide by 2. So if you're coming out with,
Right.
because
That's the last one.
otherwise it only divides the last number. So you have to think, I'm getting the total, even if you're not writing the total down, you're getting the total, and then you're dividing by 2. Okay? So yes, if you, like, Dee Dee, if you did it and you forgot about that and you get a number that's bigger than the scores, that should be a red flag.
Yeah.
Like, the average can't be higher than the scores you had. And then for the homework, we had a 90, a 20, and a 22. Those homework scores are not very good. So we would add all 3 of those together. And then after we add them together and hit equal, which the parentheses are to help me remember to hit equal, then we would divide by 3 because there's 3 scores. And we get 44. So now, and shoot, you don't have to, but you could drag your other numbers, like just write them over here so they're easier to see. You don't have to do that, but there's only one of those. So that is now we need to use our percents at the top. So quiz scores, I've got kind of some quiz scores, it's cut off out there. Quiz scores is 15%. So this 73.6 is going to get multiplied by 0.15. The projects are 10%. Now projects is way down here toward the bottom. So the information may or may not be in the same order. Test 1 and 2 are also 15% each. So test 1, 15%. Test 2, 15%. Test 3 counts for 20%. And the homework counts for 25%. So right now I've just got everything set up. And while you can do a lot of things in your calculator and come up with the final answer, If anything goes wrong, right? If anything goes wrong,
Final.
then your final answer is wrong, and I don't know for sure what you did. If you showed me this, I at least know you know the process, and somewhere along the line, you've probably just hit the wrong button, okay? So it sometimes crushes me to have to take like a 5-point question and say 0 points, but if all I have is an answer, and even if it's just rounded wrong, so please show work. That's just the moral of that story, that on a test, please show work. So here I got 11, why am I not writing? 11, sorry, there we go. 11.04, I got 12.6, 11.7, 12, 7.95, and 11. Then what am I going to do with all those? Add all those up. Good. I'm going to add all those up. And things don't look too good. Oh, hold on. Let's see. I'll come back.
66.2.
Hey, Chris, this is number 6 from the part 2 of the section 6. Kind of like what we did yesterday.
Hello?
Yep, Chris.
Sorry for being late. I was joining the Google Classroom.
Oh, sorry. The Google Classroom doesn't play nice with me trying to annotate on the screen. So you can see what I wrote on the screen, right?
Yeah.
Okay, good. Shoot.
Do I have the page?
What's that? You have that page, yes. It's the page that you were working on yesterday was section 6, part 1. This is on the back side of section 6, part 2. So it should be way toward the back of the binder right before the practice test.
I'm on it. I'm right on stuff right now.
Okay. So be prepared to have a question similar to this. It may or may not ask you to have to average the quiz grades and the homework grades, but where you have like the percent weighting. Okay? And then be prepared also to do a GPA question. Just want to make sure that everyone get 3.35 for question 5. Good.
You wrote the 66.29 and then you took the 9.
So I didn't mean to take the 9 away. When I let Chris in the meeting, everything went off the screen. And my quickest way to get things back to the screen is to hit the undo button. But then what it did was undo my 9. So yes, if I would keep all of it, or I could say 66.3. Right. You're like, wait a minute. Yeah. So thanks for pointing that out. So that also Chris is writing things down. He wouldn't think like, why didn't she make it 0.3 if she was going around? Yeah, that was just my quick way to get the screen back. And then, guys, you don't have to worry about number 7 on that 6 assignment because it has to do with a spreadsheet. Okay, so you don't have to worry about that. And then the next thing we're going to look at is the exam 1 review. All right?
This is what we're going to have the exam. This is what the exam's going to
Be similar.
But it doesn't have GPA. You're going to add GPA to it.
Yes, this is just a review. This is not so the Ivy Tech reviews are not as
Nice.
similar. Okay? So I am letting you know there will be, and it may be that it wasn't on this review because like it's the section right before. We don't really need to go back and revisit. So I'm letting you know there will be something similar to 5 and 6. Like there will be a GPA and there will be something with like percentage weighting. I don't recall that it actually asked you, that you actually have to like average the quizzes or something first, but no promises there. Chris, were you able to get those things written down? Okay. So next thing that we're going to look at is looking at the exam review, which should be the very next thing in your binders, everybody. So the first part is just asking you to put things in scientific notation, and a reminder that like when we see billion, like during the test, I'm not going to tell you how many zeros that has. So you need to know like up to trillions, how many zeros does that mean, or how many 10 to what power kind of thing. And then also be sure about your rounding. So scientific notation. I'm going to go through this first part kind of quick, and then if you have questions, I can come back to them. But I don't want to leave you with like what I consider the easy stuff and not have a chance to talk about any of the hard stuff, which we're already looking like time-wise we're not great. So a number between 1 and 10 times 10, and then we have to decide how many places is the decimal moved, and in this case it would have to move to the left, so it would be -6. So there are 5 zeros, plus it jumps over the 8. So billion is 10 to the 9th. But 12 times 10 to the 9th would not be scientific notation. So then I have to adjust and make it 1.2 to the 10th. Yes, times 10 to the 10th. Notice it is not 1.2 to the 10th. It's 1.2 times 10 to the 10th. And then because just the word billion tells me it's 10 to the 9th.
Okay.
But then the 12 would not have been between 1 and 10. And then these next ones, to write them in standard notation just means normal number. I'm not trying to be fancy on you here.
Okay.
So 10 to the 6th, so this is going to be 2. When I write down the 3 without a decimal, that's one of my places, and then I need 5 more zeros.
5 more zeros.
And then add your commas so it's easy to read. Also, 10 to the 6th,
Comma or dots?
commas. In America, commas and the dots are the decimal place. I know it's a change for you. Okay, so, and when I read it, that's 2,300,000, which should make sense because it's 10 to the 6th, so it should be 2 million. And then the next one, it has a negative, so we're going to be going back to the left. It would be one place to jump over the 6, and then 4 zeros. Now, if you also want to put a 0 in the ones place, you can. But the 5 places are from here to there.
But you gotta have 5 zeros.
Again, you don't have to have this place. You only need 4 zeros between the decimal and the 6. The 5th place is what got it across the 6.
Okay.
Number 3 is just asking about a ratio, but it is saying it wants the ratio for how many vacation days you have to working time.
Is it 44 weeks divided by 5?
No. So
You have to convert.
we need to change the weeks into days, into work days, right? So if we work 24 weeks, we worked 24 times 5, and then we're getting 8 days off. Now, this is important. Pay attention to the order. It says write the ratio of the time on vacation, so that's going to go first to the work days.
8 days of vacation?
8 vacation over 120. Since they're both in days, I don't have to write days. So 8 to 120, and then it says simplest, write it as a fraction in lowest terms. So we need to reduce. 8 actually divides evenly into 120 to make this 15, I believe. 1 to 15.
One day each 2 weeks.
1 day for every 15 working days,
15 work, I'm sorry.
which would also be the same as 1 day for 3 work weeks. But you can just leave it. It just says write it as a fraction. So in this case, just write it as a fraction in lowest terms. We don't have to add a lot of words here. Then we also may have to do some adjustments with scientific, like multiply and divide with scientific notation. So we could change them both to regular numbers, but if your answer needs to be in scientific notation, that's a lot of extra work. So we can multiply the number parts and add the exponents if it's multiplication. So this would be 19 times 10 to the 9th, and then is that in scientific notation? Like perfect scientific notation? No, we need to adjust.
Right, 1.9.
1.9 times 10 to the 10th. So if it's too big of a number, it will add to the exponent. And if the number was too small, like if it was 0.19, we would have to take away from the exponent. And also this says, as far as like, it says keep one place after the decimal. In this case, that works out nicely because that's how many places we have. On the next one, we're going to have, when I do 8.9 divided by 2.103,
4.2.
we end up with 4.23, and that even is rounded, right? And then when I subtract my exponents, I have 10 to the first. So my final answer is just going to be 4.2 times 10 to the first. Because it says round to one place after the decimal. Now I did the same thing as you. Initially I left it with 2 at first because if I would have had to move my decimal place, I might have needed that 3, like depending on which direction the decimal moved.
4.23, 10 to the first will be okay?
So because the directions are very specific, look right above it.
The first after the decimal.
So round to one place. So because the directions were specific, if the directions weren't specific, 4.23 times 10 to the first would also be okay. Now we have, in 5, we have a percent problem. So we can use a proportion. In a class of 24, 78% of the students. So the 24 that's how many students. So the 24 is the base. We want to know how many got the B or better. 78 is, of course, over 100. And you could also have done 0.78 times 24, and then it tells you round this to a whole number, which makes sense because they're people. So you should come up with, after you have rounded it, 19 students. I just cross-multiplied. Number 6, I think there is a question like this. We didn't look at the deficit and surplus very much, but this is kind of an easy question, so I kind of hate to take it off. So if it's surplus, it means you have extra money. If it's deficit, it means you're spending more than you're making. So if the expenses are $1,923 and the sales are only $1,700, then we know we're losing money. So we could say there is deficit spending, and then we would subtract because one of them is a positive thing and one is a negative. So
we'll subtract the
just take the smallest from the largest, yes. And we're not going to say negative. We're just going to use the word deficit if I see that the expenses are more than the sales. If the sales would have been higher, then we would say surplus. Okay. And then 7 is what we just did. on the other, because it's a weighted average. When we're trying to figure out, like, what was their average stars on their movies. And we would think about how many reviews. So I'm just going to write an answer over here, and you can go back and try to figure it out, because it's very much like the things that we just did earlier today. So 3.9 is your goal. So again, I would say, come back to that one and try it. But we have some other things I want to make sure, because we have not. It's been a hot minute. So these are restaurants in the country. Okay. Right. So we're going to calculate a ratio of Subway restaurants to McDonald's as a decimal to the thousandths place.
You gotta move the decimal one side.
So
Two to the left or two to the right?
slow down. Just slow down. We got it.
Sorry.
It's okay. So Subway to McDonald's. So in the order it's given, here's my Subway on top, my McDonald's on the bottom. Now, is this part to part or part to whole? Part to part, right? Subway is not a part of McDonald's, or McDonald's a part of Subway. So this is part to part. Since it is part to part, your meaningful sentence cannot be a percent. Okay?
Right.
All right. So we're gonna write. So now to make this as a decimal to the thousandths place, I would write this down first. What I just did. Now you're gonna just type that in your calculator.
I'm sorry, Carol.
No.
It says here, calculate the ratio of Subway. So when you hear of Subway, that doesn't necessarily mean it should
It's
be.
not like the percent of. Yeah. It's just you want to keep it in this order that it's given. Subway to McDonald's. I can see where that could be misleading.
They divided.
So 25,549 divided by 14,149. 46, whoops, 146. 806. Okay? Because to the thousandths place. So that means we're going to keep 3 decimal places. And now we're going to write a sentence.
Okay.
So what could we say? What could our sentence be? I could say there are 1,806 Subways for every 1,000 McDonald's. Do you guys see how I got that?
Yep, to the thousands.
Because since it's for the thousandths, and there are more Subways, that's why it's a whole number, so we should expect that that's... Now, someone might also say there are nearly 2 Subways for every McDonald's.
Right. Okay.
That would also be true, right? But we still need to give that 1.806 number because that we were asked for that. So in part B, we have the ratio of KFC, Kentucky Fried Chicken, to total.
So this is going to be a percentage.
So this one, then, it is part to whole
You said 2 total?
to the total, yes. And the
Okay.
total is already there for us. We don't have to add it up.
This is a part to whole, I mean.
Part to whole. So if you're comparing to the total, that's going to be part to whole. It still wants us to give our decimal to the thousandths place, but then our meaningful sentence, we could still use something about 1,000.
Right.
We could say this many restaurants out of every 1,000 are KFCs.
Well, it's...
Out of every 1,000 restaurants.
Right.
Or we could use a percentage. You have an option to use a percent.
You could say there are 280 restaurants for every... 280 KFC restaurants.
Out of every 1,000
So
restaurants.
do you move the decimal over to 2 places to the left?
Yeah, okay.
Of every
I mean, to the
1,000.
Other restaurants. Or
Total
all
restaurants.
other restaurants.
I can't hear you.
Or you could say 20% of all restaurants are KFC.
Was it 20%?
28.
No, 2.8.
It's
28%.
28%.
28%, right?
0.28.
Yeah, 0.28. So that's 28%, right?
Yes.
28%.
Yes, so we could use 28%, or we could say 280 out of 1,000. 28% works nicely. Percents work nicely when it is a part to whole.
Carolyn,
Yes.
if you're writing, I can only see the top of the ending for us.
The part to whole thing that I have circled is the last thing that's on the screen right now.
Okay.
So you wouldn't miss anything.
So 28% of all restaurants are KFC's restaurants.
Yeah. Now, in this case, this is basically simply your of the restaurants listed, because there's a lot of restaurants, right?
Right, that's what I was gonna say.
So-
I mean, if you say
so-
all restaurant, that it's.
So of these total stores, because like we can think of a lot of restaurants that aren't in that list. Exactly. So this worked out will be 28% of the total stores. We could say of the total stores listed.
Or 28% of all the listed restaurants
Mhm.
are KFC.
Or KFC, yeah. Because we know that that doesn't include every, oh, thank goodness.
Yeah, right?
I don't go out to eat that often, but I'd go out to eat even less if those were my only choices. All right, during a charity event, if a group raises $1.62 million and there were 790 people in attendance, what is the average money per capita? So what does per capita tell us?
For every person.
Per person, exactly. So this means we need to do 1.62 million, which we could also write as 162. I mean, we could put the zeros back on, right? We could write that. We could type that in our calculator probably pretty easily. I would only be adding 4 zeros because I moved the decimal 2 places. And then we would be dividing that by 790.
Is it okay to round it, or just do you want, since it's money, do you want?
I would say money, since it's I would go with dollars and cents.
20, 25, 31.
I'm not saying no. I'm just not saying.
And
2020.
I'm sorry.
Red.
Oh my gosh. I'm out of it. Something switched.
I came up with $2,050.63.
That's what I came up with. Yep.
1.6 to, okay, you're probably right.
Yeah, I'm looking back at what I have typed in. And then please, I'm being a little lazy to try to get through a few more examples. But please, like, write your sentence. So we could just say, the group raised $2,050.63 per person in attendance. And then we have per capita down here with the hospitals. And these are going to be little tiny numbers. Keep in mind, how many hospitals per person are there? We're not talking people per hospitals. We're talking hospitals per person. There, you know, it's a very small decimal.
12 divided by 0.06.
So we would have, so here, to get this, we're going to do, hold on here. We would be doing 12 divided by 867,000. Do you see how that's .867.
67,000.
Yes.
You put 3 zeros.
Yep. And it says we're going to round our per capita to 6 decimal places. Now, we have 1, 2, 3, 4 of those decimal places are zeros, correct?
101.
I have this, and then it would be 1, 4.
I'm sorry, I'm looking at the per 100,000. Sorry.
Did you have .000013841?
Yes.
Okay, so then round it to 6 decimal places would look like what I have right there.
So would it be 2.708?
Now, 100,000.
That's what I was talking about.
Okay, so tenths, hundredths, thousandths, 10,000ths, 100,000ths.
So 1014.
So 1.4.
Okay, so four zeros, that's 1,000.
3 zeros is the
I'm sorry,
1,000.
1,000 zeros.
So here's
Oh, yeah.
okay.
10,000,
So
100,000.
here's an easy way. After you get the decimal, since it says per 100,000, you could take this answer times 100,000. Like if you don't trust yourself, just leave the answer in your calculator times 100,000 to get the last part. So for 100,000 people, there are 1.4 hospitals for every 100,000 people.
There are one for hospitals for every 100,000.
Which would be like saying there's 14 hospitals for every million people,
Right.
if I change the scale.
Or 3 hospitals for 300,000.
There would be about nearly 3 hospitals for 200,000 people.
I'm sorry, for 200,000.
Right, but since it says write a number of hospitals, even for per 100,000, even if it still sounds kind of clunky, just go ahead and use there are 1.4 hospitals for every 100,000. Now, if it just asks you meaningful sentence,
You have to scale it up.
then you could scale it up or down to make it more meaningful. But to make things the simplest, and this would be in Indianapolis. And so obviously then Chicago, New York, Miami, same process. But like Chicago and New York, we are dividing by, we're going to have a whole nother 0 on there. We're going to have to add 2 more zeros. We'll have 2 7 and then 5 zeros. Because to get rid of the million, or you could work in scientific notation, but since we need the decimal, it may be easiest just to leave it. So here I would do 31 divided by 2.7 million. There's 1 place, 2, 3, 4, 5, 6. So 5 more zeros. That's what I would be working with. Or you could do scientific notation and then write it as a decimal.
So same as above, but it's 11 instead of 45.
Four zeros again.
11.
Which means we've got 1.1, right?
Right.
And then ask about the hospitals on the next page, because the next two work the same. So I'm going to look at the next page. You're going to need information from that page, so just be
From
prepared.
Indianapolis.
For what page?
So right here on the next one. If the number of hospitals per capita for New York was the same as Indianapolis with respect to population, so we're going to use Indianapolis numbers. So we're going to have hospitals, population. So I can go 12 over, and these are in millions, so I could do 0.867. And then expect it for New York. Don't use New York's actual hospital,
Population.
but use New York's population. And notice for both of them, you could use the actual numbers, or if you just chop the word million off of Indianapolis and New York, you could use what I have currently. Do you see where I'm going with that? Chris and Jess, I am, oh, no, never mind, I already ended, they'll figure it out. I am recording it, sorry, on this other thing. So, my 12 over 0.867 equals x over 8.4, 12 times 8.4 divided by 0.867. So I came up, what's our question? How many, so I came up with 116.3, or 100, so round to the whole number, so 116. Did anybody else work that out? Did you get the same thing? How many does New York actually have? They actually only have 62. And if I'm if I wrote a sentence, if I was asked to write a sentence, I would say, if the number respect to population, New York would be expected to have 116 hospitals. In number 12, if you need 50 minutes to complete one section of homework, you can do a proportion, or this is just one section. How much would you need to complete 6? You just need to do 50 times 6. And you could leave it in minutes, or you could change that to 5 hours.
But what would the equation be? Just simple multiplication?
Yeah, or like the proportion that I wrote, like minutes to homework, minutes to homework. Because if it wasn't one section, if it said 50 minutes to complete 3 sections, or 2 sections, or whatever.
So 1 over 50 equals
If you did 1 over 50,
6.
then you would do 6 over x.
x. And if you do 50 over 1,
Then x over 6. And then I just cross multiply. There's just no division step since the 1 is across from the x. And then 13, we've got percentage of people who smoke. Okay, so Austria has the record for the highest percentage of individuals in a country that are smokers.
So they
So Austria, as in next near Germany in Europe. So the population, that's going to, if we're wanting the percentage of total population, the total population would be on the bottom.
Yeah.
The smokers would be on the top. And then we're looking for the percent out of 100. And then this says what percentage to the nearest tenth. So you're going to keep 1 decimal place. Tenth would be 1 decimal place.
And this could, okay.
So lots of different applications for percents. If I recall correctly, we did problems like with taxes and the property value, and if I recall correctly, that is something that's percent that actually is on there. But just pay attention to which things should be in the base, because you're going to get a very different answer if you don't pay attention to that.
But usually the answer would not make sense.
Right. If you give it the reasonable test, it's not going to make sense if you've used the wrong number for the base.
So you could do 36.3, right?
So that would be 36.3%, yes. So that would be more than 1 out of every 3 people. Okay, there are 2 more problems, and I know we're right at 12 o'clock, but I'm going to go ahead and get through them. So. I found it interesting. These are materials I was given by Ivy Tech. I found it interesting that they chose to like the beer and stuff, but whatever. We'll go with it. So, the strongest beer ever sold contained 55% alcohol, which doesn't sound much like beer. It sounds more like some hard liquor, right? Yeah. So, how much alcohol is in each bottle of 16-ounce beer? Well, let's place the things we know. Again, proportions, we know.
6%.
We know.
5%, like in the alcohol.
So 55% has to be over 100 because it's the percent.
Oh, 55%.
Which one would be the base? The 16, because that's the whole bottle.
Yeah, that's
The
the
alcohol is only part of what's in the bottle.
Okay.
If you came up with an answer that's, if you put it the other way, you're going to come up with something more than 16 ounces. You can't have more than 16 ounces of alcohol in a bottle that's...
16.
And now, our reasonable test should say this should be more than 8 ounces. Because 50% would be half. So,
I just look at it as the 100 is the percentage that we need. You know what I mean?
Right.
Because that's times X.
Right. So then we should get here, I believe, 8.8. Anybody? Yep. And again, 50% is half. So just as a benchmark, if it's 55%, it has to be more than half alcohol. So 8.8 ounces, that's supposed to be a Z. And then you will have CPI question. So remember, CPI also was something we had more than one way to set up in a proportion. So if this was $80,000, and that was for 1986. So if I put the CPI, I kept 1986 together.
Yeah.
You could do...
That's easy. I found it easier.
You could do CPI and CPI together, but I think it's easier to keep the year together.
Yeah.
So that's how much in 1986. That's the CPI for 1986. The expected salary, so again,
2013.
for 2013, what's our CPI?
Over 232.
232.957. And use that whole thing. Don't do any rounding until you get to the end. And then cross multiply and divide is once again our best friend. Now, what is that? What is missing from that from just to be,
The dollar sign,
what else is missing from that?
You
you gotta move the
gotta,
decimal.
scientific notation,
I don't have to do scientific notation.
undo it.
Move the decimal.
Somebody's going to be pretty,
Sorry, 170,000.
I just said that.
yeah. So you could move this over and give me, you could just tell me this, 170,000 would be okay. Or you could tell me something like that. Or I guess if I did that, maybe I even would make this 42.
So if that comma was a dot, that would be $170 and zero.
Okay, so be sure we don't have to put the 1,000 in the formula, right? If we can leave 1,000 off the 80, but when we get the answer, like, you should not be telling me that his salary is $170.
Yeah.
What if I put 170,041 without any commas or?
That's okay. Yeah, the commas are just to help it make it readable. But if you stick decimals in by mistake,
Right.
that changes the values. Yeah. Okay.
It's actually kind of funny because I used to have a lot of people call me that a while ago.
We'll just call him Randrew.
Oh, don't start with
There you
that,
go.
because that's what happened when I
Random.
told him my first legal name. Now they just don't